The idea in subtracting fractions and mixed numbers is pretty much the same as the idea of adding, in the sense that we need common denominators in order to begin the process, and then we deal only with the numerators. For example, if we want to subtract 1/5 from 4/5, then we notice that we have common denominators, and all we do is subtract the numerators. So this is really 4 minus 1 over the common denominator 5. So the answer is 3/5. A lot of times when we subtract, we'll set up the problem vertically. And here 7/12 minus 4/12. Now notice we have a common denominator already, so we don't have to make common denominators. And all we're doing is we're dealing with our numerators. 7 minus 4 would be 3. So this is 3 over the common denominator 12. Now we see that we can reduce the fraction for the answer. 3/12. We have 3 that can cancel with the 3 in 12. And there are a lot of ways of thinking about this, a lot of right ways to deal with it. If we simply say 3 into 3 goes 1 and 3 into 12 goes 4, that's perfectly all right. Now another way to think about it is like this. We can actually rewrite this as 3 over 3 times 4 and now cancel the 3's. Just realize, though, that when you cancel the 3 in this numerator, what's left is an understood 1. So it's important to have 1 over 4 and not 0 or just nothing in that numerator. A 1 is left. And really you can think of this as 3 times 1. You see that we actually have here, and the 1 is understood as the factor partner in the numerator. Okay, to get 1/4. When the denominators are not alike, we need to find a common denominator and rewrite the fractions in order to prepare ourselves for subtraction. It's very similar to the idea of addition. So here we would identify the common denominator as 12, and we would change these fractions into new ones with denominators of 12. Now, I think it's kind of important to bring over the minus sign here for us to understand that we're subtracting. When we were adding, it didn't make so much difference. But with subtraction, I think it makes a little more difference with subtraction. At any rate, let's see, we need new fractions. 6 into 12 goes 2. 2 times 5, 10. And down here, 4 into 12, 3. 3 times 1, 3. And now we're ready to subtract. 10 minus 3 is 7. So this is 7/12 for our answer. Here we have mixed numbers involved, and once again we don't have common denominators, so we need to go out to the side and find those common denominators. Let's make sure that we bring over the whole numbered parts, and the common denominator is 12, so let's put those in and now identify the numerators. 4 into 12, 3. 3 times 3, 9, and 3 into 12, 4. 4 times 1, 4. Draw the line and subtract. Now, when problems involve mixed numbers, and if they happen to be more complicated, maybe more complicated than this one is fairly easy, but if the numbers get fairly large, then separate your thinking into the fraction part and the whole numbered part. You know, just get your head into one part of the problem at a time so that it doesn't seem so convoluted. So here we would think specifically about the fractions. 9/12 minus 4/12. 9 minus 4 is 5. So we have 5/12 for the fraction part. And then we shift our thinking to the whole numbered part. 4 minus 1, 3. So 3 and 5/12 for the answer. Here's an interesting situation. It almost looks trivial, doesn't it? We have 7 and we're going to subtract 3 1/4. The problem with it is that we don't have any fractional part up here to take 1/4 away from. We need some fourths up here. And to find some fourths, we come over to the 7, you see. We're actually borrowing from the 7. So we're going to think of 7 as 6 plus 1. And the 1 we're going to think of as 4/4 because we need a bunch of fourths to subtract 1/4 from. So we think of 7 as being 6 plus 4/4, and we're going to write it as 6 4/4 like this. Now the whole process can happen very quickly, but it's important to know what we're doing mentally in order to write in our next step that we have 6 4/4 up here. And now we're going to subtract 3 1/4, and away we go. Again, we're thinking fractions and whole numbers kind of as separate events. 4/4 minus 1/4, 3/4. And then 6 minus 3, 3. 3 3/4 for the answer. Here we have a situation where, gee, it almost looks trivial, doesn't it? Because we have common denominators already, so let's go ahead and subtract. We have 1/5 minus 3/5. Uh-oh, we can't take 3/5 away from 1/5. There aren't enough fifths up here for us to take 3/5 from. So we need to go somewhere, neighborhood grocery store or somewhere, and pick up some fifths to subtract from. Well, we do that by going over to the sixth. Now, remember, what's going on here is similar to what happened before, that what we have is 6 1/5 like this. And we can think of it as 6 plus 1/5. And we're going to borrow 1 from the 6. So we're going to think of 6 as 5 plus 1. And the 1 we're going to think of as 5/5. And now, by our associative property, you see we can think of adding those. So this is really 5 plus 6/5. You see, and we'll write it as 5 6/5 together, you see, without the plus sign. So 6 1/5 changes into 5 6/5. Now, the fast way to do that, I mean, you're not going to go through all of this in every problem like this, but once you realize you need to borrow, then you think, okay, the 6, we're going to borrow from the 6, and it becomes 5. Write that down very quickly so you don't leave it out, so you don't forget about that. All right, so you borrow 1 from the 6, it becomes 5. Now, the 1 that you borrow is really 5/5, so mentally add 5/5 and 1/5 to get 6/5. So that's the idea. Then minus 2 3/5, and away we go. So 6/5 minus 3/5, 6 minus 3 is 3. So this is 3/5. 5 minus 2, 3. 3 3/5 for the answer. Here we have 8 1/4 minus 5 2/3. We need a common denominator in order to subtract. So we'll identify the common denominator between the 4 and the 3 as being the least common multiple, or 12. So let's go out to the side and change into new fractions whose denominator is 12. We're bringing over the whole numbered parts as well. All right, here we go. 4 into 12, 3. 3 times 1, 3. And downstairs, 3 into 12, 4. 4 times 2, 8. And now we're ready to subtract. Now we're ready to take 8/12 from 3/12. Uh-oh, we can't take 8/12 from 3/12. We don't have enough 12ths over here, so we're going to have to borrow from the 8. So away we go. We go out to the side, borrow 1 from the 8, it becomes 7. Write it down quickly. All right, now the one that we borrow is really 12/12, and we add 12/12 with 3/12 to get 15/12. So 15/12. And now we're going to subtract 5 8/12. And let's see, for the fractions, 15/12 minus 8/12. 15 minus 8, 7/12. And then 7 minus 5, 2. So 2 7/12 for the result. Here's a word problem, and I'll rather than reading a word problem, I'll explain it to you. We have kind of a cylinder, and let's say that this is a pipe maybe, or a bushing or something like that. And we have the outside dimensions as 3 3/8. That is, from the outer part here to the outer part over here is 3 3/8. And what we'd like is this inner part. And we know that the thickness, that is, this thickness right here, is 1/4 of an inch, 1/4 of an inch. And we'd like to know the inside dimensions. That is, we want to know this distance. You see, that inside diameter. We have the outside diameter. We want the inside diameter. Now, we know we have some subtraction to do, and there are several right ways to work this. We could say, okay, let's take this outside dimension, this outside diameter, 3 3/8, and let's subtract 1/4 for this little thickness over here. But then we would have to take the result of that, and we'd have to subtract another 1/4 because this is 1/4 inch over here as well. You see, so we'd have to do 2 subtractions. Another way to approach it is to say, well, what's the total of everything we're taking away? We're going to take away 1/4 inch over here and 1/4 inch over here. So what's the total amount we're going to take away. Well, let's see. It would be 1/4 of an inch plus 1/4 of an inch. 1/4 and 1/4, oh, that's 2/4. And 2/4 reduces to 1/2. Okay, so we're really taking out 1/2 an inch from this overall dimension. Okay, so now we can make that subtraction like this. Now I've run out of board on the right, so I'm coming back to the left here. So it's 3 3/8, and we're subtracting 1/2. Okay, 3 3/8 minus 1/2. We need a common denominator, the least common multiple, or the least common denominator for 8 and 2 would be 8. So this one is already, this mixed number, the fraction part particularly, already has that common denominator. And now for this part, we say 2 into 8, 4. 4 times 1 is 4. And now we're ready to subtract 3/8 minus 4/8. Uh-oh, we can't take 4/8 from 3/8. We have to borrow. We borrow from the 3, and it becomes a 2. And the one that we borrow is really 8/8. 8/8 and 3/8 is 11/8. Now we can take 4/8 from 11/8. 11 minus 4 is 7. So this is 7/8. 2 minus 0 is simply 2. So 2 7/8 is the 2 7/8 inches is the inside diameter for that bushing.